Topic is gradient, unit normal vector and directional derivative. Each one problem. The first question, if 5 is given in the question, phi of x comma y is given in the question, find del 5 at a point. It's easy. Only del 5 first we need to write. Everyone know to write del 5. What is the formula for del? Del is nothing but I into dou by dou x plus j into dou by dou y plus k vector into dou by dou z into phi. It is given in the question. X squared y plus y squared x plus z squared. So first step, like this you have to write. Next step, you have to multiply each time. Okay, this 5 is for all the 3 terms. So split and write it. So I vector dou by dou x of the full question. So x squared y plus y squared x plus z squared plus j vector dou by dou y x squared y plus y squared x plus z squared plus k vector into dou by dou z of x squared y plus y squared x plus z squared. So now differentiate I vector as it is. Dou by dou x of the full question with respect to x. Where x is involved? Only in this x, in this x. I don't have in this x. Okay, so in this x. So when I differentiate, I'll be getting the answer to be 2xy plus in this x I'm going to differentiate. Y squared is like a constant. X when I differentiate 1 plus j vector. Same way differentiate with respect to y. I have in 2 terms y. So x squared is like constant. Y when I differentiate 1. In this x is a constant. So when I differentiate y squared is nothing but 2xy plus z vector into with respect to z only one term. So 2z. So completed. Del phi completed. But the question is this asked del phi at a point. Okay. So substitute at 1, 1, 1. At x equal to 1 you have to put, at y equal to 1 you have to put, at z equal to 1 you have to put in the given right hand side. So del phi we will calculate. Del phi is nothing but I vector as it is 1 when I put x1, y1. So 2 plus 1 plus j vector 1 plus 2 plus k vector into 2. So simplify this and you write del phi is nothing but 3i vector plus 3j vector plus 2k vector is my answer, final answer. Second problem, I'll change the color. The second question. What is my second question? So my second question is find the unit normal vector to the level surface at a point is given. Unit normal vector already we have studied in my first video, formula video. You check in the formula video. So unit normal vector, the formula I already have given. It's nothing but n cap is nothing but del phi divided by determinant of del phi. 5 is the given question is 5. Given question is 5. So that first step we have to take it and write. X squared y plus 2xz minus 4. Okay. So this is our del phi. Okay. So now I have to calculate it. So when I calculate it, so del phi, first del phi I have to calculate. Del phi only I have to calculate. Del phi means del first step we have to write I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z into the given question 5 x squared y plus 2xz minus 4. Okay, now I vector into dou by dou x into x squared y plus 2xz minus 4 plus j vector dou by dou y into x squared y plus 2xz minus 4 plus k vector dou by dou z x squared y plus 2xz minus 4. So differentiate this I vector as it is. With respect to x, I have to differentiate this x, this x. So 2xy plus 2z plus j vector. When I differentiate, so j, I have y only in this. So x squared. K vector, I have it in this. K vector 2x. So at del phi at a point given point 2 comma minus 2 comma 3 I will substitute. So I vector as it is. So 2 x I have to put 2, y is minus 2 plus z 3, so 6 plus j vector x squared, so 4 plus x 2, so 4. So when I write it here I will be getting, so 4 4 2s are 8, so 8 minus 8 plus 6 minus 2. So answer will be minus 2 I vector plus 4 j vector plus 4 k vector is my del phi. I have to find determinant of del phi. So determinant of del phi is nothing but determinant. How we have to write it means I vector the corresponding coefficient the whole square. So minus 2 the whole square plus j vector the whole square 4 squared plus k vector the corresponding coefficient the whole square 4 squared. So square it. So 4 plus 16 plus 16 36 root 36 is nothing but 6. Okay. So now finally write n cap. N cap is nothing but del phi by determinant of del phi. So minus 2 I vector plus 4 j vector plus 4 k vector divided by 6. This you simplify it. 2 you can take commonly out and you cancel it and you write. So it's nothing but minus I vector plus 2j vector plus 2k vector divided by 3 is my final answer. Completed. The third question I will use some other color. Now my last question, third. Find the directional derivative of f at a point in the direction of the vector. Okay. So f vector is given in the question. Okay. First f vector is given means directional derivative. What is the formula? Directional derivative. In the formula video you check what is the formula. So directional derivative is nothing but, okay, so the formula is del f into a cap, where a cap a vector divided by determinant of a vector. Okay. So this a vector is the given question, or it can be written as a 5 vector. It's not wrong. Any one notation. Okay. So a vector or 5 vector, anything you can denote it. So now we will calculate first del phi. So del phi I need to calculate del into f. Okay. So it's nothing but the dot product. So dot product everyone know del is nothing but I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into the whole question f x squared y z plus 4x z squared. Okay. Now I vector into dou by dou x I will find out directly answer or you write one more step. X squared y z plus 4x z squared plus j vector dou by dou y into x squared y z plus 4x z squared plus k vector into dou by dou z of x squared y z plus 4x z squared. So now differentiate. So it's nothing but I vector as it is dou by dou x. In both x I have, so it is 2x y z plus 4 z squared plus j vector. So y I have it in only one term, so x squared z plus k vector. I have it in both the terms, so x squared y plus 8x z. So completed. Now we have to substitute. So at 1 comma minus 2 comma minus 1 del f at 1 comma minus 2 comma minus 1. I will complete that. So I vector, so 1, so what you have to put for 2 as it is x1 y minus 2 and z minus 1 plus 4 z squared, so 4 only, plus j vector, so x1, so z minus 1, so minus 1 I will be getting, k vector x1, so y is nothing but minus 2 plus x1 and z minus 1, so minus 8. So when I simplify it, I'll be getting 4, so minus minus plus 4, 4 plus 4, 8. So 8 I vector minus j vector minus 10 k vector is my del f, del dot f. Okay, now a vector is given in the question. A vector is given in the question. So a vector 2i vector minus j vector minus 2k vector. So determinant of a vector I will calculate it. Square root of 2 squared plus minus 1 the whole square plus minus 2 the whole square. 4, 4, 8 plus 1, 9. Root 9 is nothing but 3. 3 I am getting. So now n a cap. A cap is nothing but a vector divided by determinant of a vector. So 2i vector minus j vector minus 2k vector divided by 3. So completed. This both I have to multiply it. This is my first equation. This is my second equation. Both if I multiply, it's nothing but directional derivative. I have to multiply that. So my directional derivative del f into a cap. Okay. So del is nothing but 8 I vector minus j vector minus 10k vector into a cap is 2 I vector minus j vector minus 2k vector by 3. Everyone know I have to multiply this. Everyone know that I vector dot product of I vector is nothing but 1. I vector with respect to j or I vector with respect to some k, it is 0. Okay. So any other multiplication I cannot multiply it. Only the same vector I can multiply it. So I into I, j into j, k into k. Remaining everything 0 it becomes. So this both when I multiply it, 8 into 2, so 16 minus, okay, minus 1 into minus 1, so plus 1. So minus 10 into minus 2, so plus 20 divided by 3. So it's nothing but when I add everything, I'll be getting, so 37, correct no? So 21, so 37 by 3 is my directional derivative. My answer is 37 by 3. My directional derivative is always directional derivative you will be getting in the terms of numbers only. 37 by 3 is my final answer. Thank you.